So hello, my name is Himanshu Sekar and am MSc Mathematics graduate from Indian Institute of Science Education and Research, Thiruvananthapuram. Okay, today we are going to start the new chapter, ordinary differential equation. Okay, firstly introduce what is the relevant of this course. Okay, so this course is basically for CBSE student, ICSE student. Of course, obviously it's a class 12th student. So CBSE student and ICSE student, and also it is benefit for JEE mains and JEE advanced student. Those who are preparing for engineering to get admission in IIT or NIT. Okay, so so let me first write what is the prerequisite of this course, or if we can say in another form, or if I can say in the refreshed form. So we can of like sets, function and some type of mapping. Okay, so chapter ordinary differential equation for CB, AC, IC, GE and advanced student. Okay, this is basically tools we are gonna use. First sets, second function, and third there is a type of medical structure. Mathematical structure. Okay, firstly is what is differential equation and how it is look like. Okay, so then we are going to what is the type of differential equation, how if we can generalize these things, how it will look like. Okay, what is introduce some kind of sets and mapping use in real number. On a real number we are going to take the assumption on a real number, so we can't assume on any complex number or any set. Okay, so basically we are going to take in on the real number on the real axis, and also along as solution of the ordinary differential equation we are going to consider on real line. It means solution of the differential equation is taken from the real line. Okay, so first note, we are talking in real line. Because if we are talking on not on real line, and if we are gonna use to take from the complex number or to the solution of the ordinary differential equation may be vary, and it can be most complex, or maybe sometimes it will be difficult to analyze something take on the real line. Okay, so firstly I'll introduce some type of function. Okay, so let if R to R be a some kind of you can say it is a function. It is a function is called operator. That means operator. Okay, so I'll tell you, this definition is most popular. Based on this definition, we are going to find different type of ODE and also kind of a structure of the differential equation. Okay, so and based on this definition, most of the questions are asked in JEE Main and also in JEE Advanced based on this definition. Okay, so this is the most important. So there is another kind. This definition is mostly famous. We are going to use everywhere in the mathematics and mostly used in ODE and also used in the function. Okay, later also going to make a video on a function and sets. Define C AB is a set of all continuous function. And remember, I'm already tell you, we are going to talking on real number. Okay, so all f, that is element from X, and mapping those elements are going in the same space, that is R. Okay, if R to R. So CAB is a representation, and so CAB is a collection of all such function which is continuous and defined from F R to R. Okay, so in this way we are going to generalize this CAB. We are going to define a set of all continuous function from R to R. Okay, so here not R to R, it's a function f defined on AB. It's a certain on interval. Okay, not defined on a whole. Here defined on a whole R, so here we have to take C on R. Okay, so CKAB, it means set of all kth continuously differentiable function f on AB. Okay, so and here if k is equal to 1, so firstly see, if k is equal to 0, it is CAB. K is equal to 0, it's CAB. So it is a, so only it's a continuous function which is defined on AB. Okay, K is equal to 1, C1 AB. Okay, so this is a set of all 1 times continuously differentiable function defined on AB. And note, set of all k plus 1 time continuously differentiable function on AB is a subset of C, set of all continuously differentiable function defined on AB, and this is true for all k belong to natural number union 0. So okay, so there is question comes, so in your mind, if k is equal to infinity, so what does that happen? K equal to infinity, C infinity AB. So it's a similar case, set of all infinite times continuously differentiable function f on interval AB. Okay, set of all infinite continuously differentiable function f on AB. Okay, and if I'll give you one example, most famous example is if x is equal to e power x. This is an infinite times differentiable function. Okay, and so what your job here is to think. You have to take example based on this. Based on this type of sets, we are going to take many types example, and based on these sets, we are gonna to see various type of example and question that is most famous asked in JEE Main, JEE Advanced, okay, and also other competitive exams. Okay, so mostly famous it is asked in ICSE board, but I'm not sure it is asked or not, but I'm pretty sure. A function if R to R. Remember, if we define a function f on the space R to R, here we can always take a subset of R, either itself R or a subset of R. We are not going to take here f defined from complex number C to complex number C. Okay, we are always going to define from f R to R. So class 12th and up to IIT JEE advanced syllabus, the syllabus is only for function defined from R to R in ODE. Okay, a function f is differentiable. LHD is equal to RHD. Left hand derivative is equal to right hand derivative. But in general, in ODE, we are going to consider solution of the ODE, or if we are going to construct the ODE, dependent variable is always be a differentiable function. We already supposed, okay, we are not going to find, or we are not going to see they are at so they are firstly differentiable or not. No, it is not absolutely. Firstly, if we are going to study in the ODE, dependent variable y is always considered to be a differentiable function, and if we are always considered to be a differentiable function, we can represent in this form. In general, in ODE, dependent variable is considered to be a differentiable. Okay, so let's say considered to be a differentiable. Let's say at x is equal to a, df by dx. When we are dealing with the question of J main and J advanced, almost the question comes based on this definition. Okay, so you should have to remember this: f prime at a, f prime at a. Most question ask based on this representation, based on this definition, in JEE and advanced. And in the later lecture we are also going to dealing based on this definition. Okay, so they are the fundamental and the prerequisite that I'll introduce you so to the lecture. And this is the most famous part of the to see how the solution will behave later on the independent variable. Okay, and most of the question based on this part. Now we are going to introduce what is differential equation, and later and after that what is differential equation, what is the type of differential equation, how it will look like differential equation. There is a type of representation of any equation that we can represent. There are two types to represent algebraic equation. First, explicit, and the second is implicit. Okay, so explicitly, any equation of y is equal to fx we can represent in this form. Okay, so example, y is equal to x square, another is dy by dx is equal to 2x, like this. Okay, but in the implicit representation we are going to represent like in this form: psi x y is equal to 0, okay, or if x y is equal to 0, okay. Our example is 2x plus y dy by dx is equal to 0. Same, here we can take same, y minus x square is equal to 0, another is dy by dx minus 2x is equal to 0. Okay, so this is explicit representation and this is a implicit representation. Okay, and mostly so the easy problem are based on this representation. We are going to dealing with the differential equation solution and also itself ODE based on the implicit. And also we are going to define, and the main definition, main formal definition, we are going to define based on implicit method. Okay, what is differential equation? What is differential equation? So the simple answer, so we can define some type of relation. Okay, so in the same way, in differential equation, if we have a certain type of relation, that is a function. Okay, the relation between independent and dependent variable, independent and dependent variable, relation between x, that, so this is independent, another, so relation with dependent variable, and dependent variable is y also. So the relation between x and y, and also its relation with the derivative part, it's dy by dx. Okay, it's relation with dy by dx, and if you have relation up to nth times derivative, okay, it's also no problem. Relation up to dn y by dxn is equal to 0. If we have this type of relation in our equation, then we can say that this is a differential equation. Okay, this is a differential equation. And if derivative is ordinary, ordinary means its dependent variable is only one. Okay, there is not present differential equation like y, z, p. Okay, so there is a one dependent variable is present, that is y, and dy by dx is a differentiable form of y. Okay, so this is all are ordinary derivative. Okay, these are ordinary derivative. So if we have a relation, or if we have a functional relation with this variable, then we can say that we have a ordinary differential equation. Why ordinary? Ordinary means it's dy dx of one dependent variable is a ordinary derivative. So that is why we can say that it's an ordinary differential equation. And obviously see, this representation is a implicit representation. Okay, this representation is an implicit representation, and then we are going to define ordinary differential equation. Okay, now we are going to define how it will look like. So, okay, a standard form of, this is a standard form of differential equation. Okay, now we're gonna to study ordinary differential equation, mostly of the syllabus of up to J Advanced and J Main, and also in CBSE and ICSE board. The only syllabus is for one order derivative. Okay, there is nowhere for the second order derivative. So for one order derivative, wait, one order derivative, it means one times derivative. It means one order derivative means one times derivative or dy by dx of y. Okay, see this part. This is a one order derivative and it's a1 dy by dx plus a naught y is equal to 0. And note that this is a one order derivative because its derivative is 1 and power on highest derivative is index. Okay, it's a basic question asked in mains, not in J advance, and don't expect this basic type of question asked in mains. Okay, sorry, advanced. They are only asked in CBSE, ICSE, JEE main. That's it. Next level, we are also going to dealing with advanced the question. Okay, for firstly we are going to develop some foundation level that no student we are gonna to stuck anywhere, and in the next lecture we are going to dealing with linear ordinary differential equation with constant coefficient. Here it is a naught a1 oh, it's a an minus 1 a1 a naught, yeah, and all these coefficient are constant, not on any dependent of the variable x. Mostly the question asked in mains and advanced based on coefficient is constant. Okay, and also in the next class we are going to see type of differential equation, what is the solution of differential equation, and how it will behave later time solution. That is mostly asked in JEE advanced exam paper. So okay, thank you.